Good morning, students. Today, with respect to data structures, we are going to discuss a new topic called linked list. Okay. Already we have discussed about the arrays, stacks, and queues. The next data structure is linked list. Okay. See, as whenever you're talking about the linked list, first question, as usual, what is a linked list? Linked list is a linear data structure. It is also a linear data structure and it contains one or more nodes. Linked list is a linear data structure has one or more nodes. Okay. See, what do you mean by a node? What is a node? A node contains two parts. One is information part. Information means data part, and another one is a link part. Link will hold the address of the next node, and information will hold the data, any type of data, whether it is a numeric data or alphabetic data or alphanumeric data. Okay. See, and a node may contain n number of nodes. Okay, one or more nodes. Only one node here we have written, and this node contains only one information part and a link part. And in the next example, we have given three nodes: node 1, node 2, node 3. Okay, a linked list may contain n number of nodes, but here we have represent three nodes. Okay, and each node contains two parts. One is information. Information is the information part. Information is nothing but a data, and another one is a link part. Link part holds the address of the next node. Okay, and similarly this link holds the address of the another node. Okay, if it is a last link, the link node will have the null pointer. Okay, means it says that it will is the end of the list. Okay. Now here also we can perform so many operations. What are the operations you can perform on a linked list? See, creating a linked list. You can create a new linked list. Okay. Then traversing a linked list, similar to arrays. It means where you are going to visit each element in the linked list. That is called a linked list traversal. Next, you can insert a new element into the linked list. Then you can also delete an element from the list. Then you can search the element in the list. Then merging two or more linked list. ನೋಡಿ ಇದು ಅಷ್ಟೇ ನಿಮಗೆ 3 marks ಕೇಳ್ತಾನೆ. Write the operations performed on linked list. Then you have to write creating a linked list, traversing a linked list, inserting an element into the linked list, deleting an element from the linked list, searching an element from the linked list, searching an element in the linked list, then merging two or more elements from the list. Okay, and okay, today we discuss about the types of linked list. Here, yesterday already I told. Okay, there are three types. One is singly linked list, and another one is doubly linked list, and the third one is circular linked list. Okay, say in singly linked list, it contains each link part, and the last part is going to be the null part. Okay, now we can modify this diagram for singly linked list. Now, first one, singly linked list. Singly linked list. Okay, it contains start pointer, then information link part. Okay, say then information info and null pointer. Okay, see node 4. Okay, this single linked list contains 4 nodes. Okay, node 1 contains on the information and link and info link. This information can be have datas here. Okay, info part means you can have the datas here. See, this can also represented like this. Start from the start point, the information part. Okay, you can hold 10, then link part, and another one 20, then link part, and another one is 30 and the link part. Okay, and the next one is 40, then null. Okay, see here node 1, this is node 1, node 2, node 3, node 4. Okay, already we told a linked list can contains n number of nodes. Each node has an information part and a link part. Okay, see this is the link part where it will holds the address of the next node. Okay, see here like this. Okay, this is singly linked list. Okay, one after the other. Okay, see in one direction, that is called unidirection. Okay, each node have the addresses. If you find null, then there is no another node. Means this list contains only 4 nodes. Similarly, it can contain n number of nodes. Okay, see in doubly linked list you have 2 addresses. Okay, in both the direction. Okay, bidirection. This is called unidirection. In doubly linked list you have both the directions. Okay, see here you can represent a link for the doubly linked list now. Okay, see second one, doubly linked list. Okay, you have a start pointer, and 2 information part, 2 link parts here. Here you can have 5 link part, then again link, some 10, again link part, then 15, none. Okay, see here this is node 1, node 2, and node 3. Okay, see this is a example for doubly linked list, and this list also contains n number of nodes. In the our examples we have given 3 nodes. This list contains 3 nodes and each node has 2 parts, 2 links here. Okay, see on both the directions, and this may be bidirection. Okay, see also it is like this, right? Okay, doubly linked list contains 2 links, and singly linked list contains only 1 link. That is the difference between singly linked list and the doubly linked list, and it works on both the direction. But singly linked list works on only single direction. That we will call it as a unidirection. Here this we will call it as a bidirectional process. Okay, see this is the difference. So this is unidirection. For single linked list we will call it as unidirection, one direction. Unidirection process. Only the possibility is at 1 link. This contains only 1 link and this contains 2 links. Okay, that is the difference between single linked list and the doubly linked list. One more linked list is there, that is called circular linked list. Okay. Circular linked list, third one. Circular linked list. Okay, for this also you have a starting node, start, similar to singly linked list only. Okay, here you have one information part, info part, and the link part, and you have an info part and a link part. Okay, similarly you have info part and a link part. Okay, but here the last link is connected to the first link, that is called circularly linked list. Okay, example, starting pointer, then information, any information you can hold. For example, okay, 25 is the data, and next pointer, and similarly next 50 is the data, and the next pointer, and the 100 is the data, and next pointer. Okay, and the last link is going to be connected to the first link. Okay, see, this is called a circular linked list. Node 1, node 2, and node 3. Okay, this type of linked list is called a circular linked list. Okay. So once again we can recap now. What is a linked list? Linked list is a linear data structure and it contains one or more nodes. N number of nodes it may contain, and each node have two parts. One is information part and another one is the link part. Okay, and information part holds the data. Already I told, data may be any type, either it is integer or floating point or character type, and the link part holds the address of the next node. Okay, like this you can have n number of nodes in the list, right? And operations already told. What are the operations can performed on linked list? One is creation, and the next one is inserting an element into the linked list. Third one is deleting an element from the linked list, and next searching an element from the list. Okay, and the merging two or more linked list. Those are all the operations performed on the linked list. And the types of linked lists are singly linked list, doubly linked list, and the circularly linked list. Okay, this is the concept of linked list. And for examination, from this point of view also you will get 3 marks, and it is very easy to remember also. Okay, and we will discuss in the next class for the another topic. Okay, thank you students.